Hello, my name is André. I'm a field engineer at Canonical, and in this video I want to show you how to install and use Microstack Sunbeam. So Microstack Sunbeam edition is basically a new version of the existing Microstack tool, but it's also almost a complete rewrite of that tool. It started in 2022. By the end of the year, beta version was released, which is what we are going to take a look in this video. And it's basically using a completely different architecture. All the control plane for Openstack was moved into Kubernetes, and we are leveraging microK for that, so it's easy to install instead of you having to install a complete Kubernetes cluster just for installing OpenStack. But OVN, Nova Compute, and in the future a few more parts will still run outside of Kubernetes. The beta release that we are going to test now has some limitations. It is only installing one node so far. This is going to improve in newer versions, but so far it's only installing everything inside that same node that you are running the tool. It still has only a few configuration options about IPs you want to use and some other questions, but also in the future the idea is to have many more questions or options for changing more stuff. And it still needs a manual OVS configuration for the machine to be able to reach the external networks and go to the internet, for example. But I will be going through that in the video, so it will be easy to follow. So for installing the tool, we're gonna need an Ubuntu server. It doesn't matter if it's a bare metal or a VM, as long as you have enough resources to run what you need. If you're using a VM, don't forget to enable nested virtualization. Use at least 4 procs and 10 gigs of RAM and enough disk space for you to create your VMs. The official documentation says 8 gigs, but that gave me some trouble. So when I started using 10 gigs instead, those problems went away. So I suggest you do that. You need some free IPs on the network. Apart from the one you're using on the VM, you need some more. You need internet access for downloading packages. You need a dedicated network interface specific for giving to OVN. Beware of some filtering that some hypervisors do on the traffic that goes into the VM. For example, VMware or even OpenStack, you need to enable some kind of promiscuous mode or disable MAC and IP pair filtering, whatever the name is. It may be blocking anything different from the original MAC address to go into the VM. And you'll be downloading lots of stuff, including many containers from an online registry, and the speed will not be great, so be patient. In my particular environment, I'll be using a VM created by LXD. My network is this one, 198.18.20/24. The gateway is .1. The HCP range in that network, which is being managed by LXD itself, is from 100 to 250. I'll basically be using just one IP in this range, which is the IP for the VM itself. But I'm reserving some more ranges on this same network for giving to MetaLB of the first range and the second one to OpenStack, actually to OVN, to be used in the OpenStack SDN. You don't need to officially reserve these IPs anywhere. I say you reserve it because I mean that I'm not using those IPs anywhere else, and I will tell OpenStack to use them, so I know there will be no conflict with anything else on my network. And also I'll be using 2 interfaces inside the VM. The first one is a normal interface as acting as a DHCP client. And the second one will be a non-configured interface that will be given to OVN later. And externally to the VM, that second interface is plugged to the same bridge as the first one. I need both interfaces because I cannot have OVN and the kernel using the same interface at the same time, even if I want both kinds of traffic to go to the same network externally. That's why I have 2 interfaces connected to the same bridge. Okay, so let's start installing. Right now I am on my laptop and I'm on the host here, so I want to create a VM to run all the installation inside that VM, so I don't mess up with my work installation. For that, I just want to show you that I don't have any VMs created right now. I will create one VM with 5 CPUs and 10 gigs of memory. And then I'll be extending or expanding the disk for that VM to 50 gigs. The full size is smaller than that. And then I will start the VM. Okay, so I'll give about 30 seconds for the VM to boot, and then I will open a shell into the VM. Okay, it should be booted by now. Yep, I'm inside the VM. And now I'm gonna add a second interface, because if you take a look at the interfaces I have right now, apart from the localhost interface, I only have one, which is acting, as I said before, as a DHCP client, and it has one IP in my DHCP dynamic range. But I need, this will be the main interface where the VM itself talks to the external world and go to the internet. If you take a look at my routing table, I'm using 2.1 as my gateway. But I need that second interface so I can give that to OVN later. For that, I'm going to go outside of the VM, and I will add a second interface, which I'm calling ETH1. I'm sure that name will change inside the VM, but that's what I'm calling that in the config for LXD. And I'm saying that's bridged, and the parent bridge is the same one as the first interface is already connected to. Okay, that was added. I'll go back to the VM, and now if I list my IP addresses or my interfaces, you see that I have this second interface here. It is not configured, which is great because that's exactly what I need. That's why I didn't add this interface before I started the VM, because then on the first boot it will configure both interfaces to act as the DHCP client. I don't want that. So I purposely waited for until the VM was started and then added the second interface. So Linux will not try to configure this interface. Even if I reboot now, it will come back unconfigured. That is great. Now we are ready to start installing all the packages that we will need for this installation. The first thing that we need to install is Microstack. So Microstack comes in a snap format, and the current release is 1.25. So I'm installing it right now. As soon as it finishes installing, I will be configuring it to use to enable some of the modules that I will need during this installation. Okay, after Microstack installs, it is still running some tasks in the background to finish the initial configuration. And I need to wait for those tasks to finish before I move on to next configurations. And for that, I will run the status wait ready command that will basically block until all those tasks are ready. And when this command releases, I'm good to go with the other configurations. Okay, now we can go on configuring the DNS module. I'm pointing here to a public DNS server, so it's easier for anyone to do and follow these same instructions, but you can be using your own DNS server if you want. This is being passed to Microstack to configure inside Kubernetes as the upstream DNS resolver for the internal DNS. Okay. Okay, now let's enable the host path storage module. Now we enable and configure the IP range for Metal LB module. Okay, this is just to avoid MicroK8's restarting. Now I will add myself to the Snap MicroK8's group, and if you take a look at my current groups, I already added myself, but it's not active yet. So I will just log out and log back in, and now you can see that that group is active. This is an important step. You need to have that group active before continuing. Okay, so now let's start installing some Snap packages. The first package that we are going to need later is Juju. We're not really bootstrapping the controller. The tool is going to do that for us, but I need to have the package installed. Another package that I need is Microstack itself. Here I'm installing Microstack from the Sunbeam channel. This is important because if you use the normal channel, you'll be using the old Microstack version. I'll also be installing the Openstack hypervisor package, which basically has the pieces that are going to be running outside of Kubernetes. Right now they are OVN related parts and Nova Compute. Okay, one more snap I'm going to need is Openstack clients. I don't need it during the bootstrap of Microstack itself, but I will need it later for interacting with the installed Openstack. So I'll just go ahead and leave it installed by now. And I also know that I will need an SSH key to use to enter the VMs. I'll just create one right now. And that's it. Those are the prerequisites that I needed to install before starting the bootstrap process. And now we're going to really start installing OpenStack itself using the Microstack bootstrap process. For that, we are going to use the Microstack bootstrap command. But before I do that, I want to show you something very interesting while it happens. So I will open two more shells here. Let me connect those two shells to the same VM. And I will be running two watches on these two shells to show you what Juju is doing and also showing you what MicroK8 is doing during that bootstrap process. Right now you can see that the Kubernetes installation is very basic, very simple, doesn't have anything special. But during the bootstrap process, the tool will bootstrap a Juju controller inside this Kubernetes installation. And after the controller for Juju is installed, it will create a new namespace called Openstack and then start installing parts of Openstack in that namespace. But that is going to happen through Juju. So you can see the interaction of the tool with Juju and Juju talking to Kubernetes. That's very interesting to watch. So let's go back to the bootstrap process. So it basically checks for the presence of some of the prerequisites. In this case, Juju, MicroK8 itself installed and running, the Snap package for the Openstack hypervisor, and now it started bootstrapping the Juju controller into MicroK8. So you'll be able to see at any moment here, Juju, a new pod coming up for Juju. Yeah, we already have the service. And now we can see the controller initializing. Okay, so now the controller is running, and at any moment now the bootstrapping process of Juju controller is going to finish, and then it will move on to create the model inside the controller, which will create a model called Openstack on Juju. There we go. And that model Openstack will translate to a new namespace called Openstack here in Kubernetes. From now on, everything that happens here in Juju in terms of installing new applications is going to happen on this OpenStack namespace here in Kubernetes. So I will just stop this and switch to that specific namespace so you don't see too much noise, and it can be easier to see the progress of the installation. Now, this process is going to take a long time. Maybe 30 to 40 minutes. That's basically what it's taking for me right now. And Juju will create all the pods here, download all the images for the containers, start everything. And even after everything is already started and running in the Kubernetes side, it will still go into those pods and configure those applications. So all this process you'll be able to see here, and when everything finishes, then this deploy control plane bundle step will finish. So I will just speed up the video and be back when this is finished. Okay, so the point of view of Kubernetes, all pods are running and services are up and the installation is basically finished. Pay attention here that we have many of the services have external IPs through MetaLB, and this is especially important for us to access these parts of control plane from the external world, for example, the dashboard. This will be important later when accessing the dashboard. Pay attention, I'll be using one of these IPs. But that's it. From the Kubernetes point of view, it's basically done. But Juju still has a lot to do. Even though all the pods are up and running, Juju still have to go inside each of the applications, configure them, process relations, copy stuff between those pods for configuration. And when Juju thinks everything is done, then this step here called deploying control plane bundle will finish, and it will move on to the next step. So let's wait a few more. As you can see, some of these charms stay in some error state for some time, but don't worry, they recover from that. Just keep waiting a little more, and eventually they will settle and all become active. Okay, so the deploying of the control plane bundle itself has finished. All the applications are in active state in Juju. So the bootstrap process is continuing on the next steps. The current step is updating hypervisor identity configuration. It's talking to those parts of the hypervisor that run outside of Kubernetes and doing some configuration on that part now. So it will just take a little more time. Let's wait. While we do that, I will just close these other shells here because we don't need to be taking a look at those parts anymore. Okay, if this happens to you, don't worry. This seems to be a small bug in the current version. During the hypervisor configuration, some communication times out and it eventually gives up with this Python error. But an easy workaround for this is just running the configuration again. So I normally wait about 30 seconds because if I run it too quickly, it will just fail again. But after a few seconds, if you run it again, it will just go over all the steps that are already executed. It will quickly skip those steps and we'll go back to that same step that gave us the error. And this time it will finish that with no problem. Yeah. It just passed that step, as you can see. Just a few more steps and then the configuration will be over. I mean, the bootstrap process will be over. And then we can move on to the next step, which is actually configuring Openstack. At this point, all the Openstack control plane is already installed. It's already installed and running. In theory, you could be already interacting with Openstack and start doing things. The only problem at the moment is that not everything is correctly configured. So we still need to set up some IP addresses, some names for Fiznets and this kind of stuff. So that's what we are going to do next, is configure the Openstack that was just installed with the bootstrap step that we just finished running. Okay, so we just finished running Microstack bootstrap, and next we are going to run Microstack configure. For the configuration part, I will be using this command, microstack configure-o, and the name of a file that I want it to write the credentials for me. I will be using this file later as the credentials for the Openstack clients to communicate with the Openstack control plane. So let's do that. It's suggesting a username for this demo project that is going to create for us. I think demo is a fine name, so I'll just accept the suggestion. This is the password that is going to be automatically assigned to that user. I also don't have any problem with that, so I'll just go ahead. This is the network that is going to be used in the internal network, where the VMs are going to be connected to. This network doesn't matter too much, it can be anything. It will not be connected to the external board, it will go through a router, and then that virtual router will be connected to the external board. So I would just go ahead and accept this suggestion. It's asking me if I want it to pre-create for me a security group with rules for SSH and ICMP. I will say yes, because otherwise I would need to create that myself, so please do that. Now it wants to know about the external world network or the provider network that I'm going to use on these routers, or for using FIPS or floating IPs for the VMs. This network doesn't need to really exist. It can be anything if you don't want to external access to this environment. But if you do intend to access this from either the VM here itself or even my laptop outside the VM, I should be using a real network that do exist. And you remember I said at the beginning that I had reserved some IPs on my network where this VM is plugged in to be used for the OpenStack control plane. So that is what I'm telling it right now. I want to use that same network that I'm already using for this VM. So here I'm saying what network I want to use. Then it's going to ask me what is the gateway in that network that is going to be used. And this information, it will be important for setting up the routers later, so they can be plugged to this provider network and use the correct gateway. My gateway is at this IP, so that's correct. I'll just accept that. Now it wants to know what is the start and end points, IPs for allocating for the floating IPs and routers. I will limit this to those IPs that I listed at the beginning. Those IPs were 20 to 59. Then it wants the name of the FISNet that it's going to be related to this provider network or this external access. It's okay, this name, I don't have any problem with that. That is going to be a flat network. Otherwise, it could be a VLAN network, for example, but then I would be creating VLANs inside that network, and this is not the case here. I don't have the ability of creating VLANs, or I don't need to create VLANs inside this network that I already have. So I just go ahead and say that it is flat. And now it's going to take all this information and apply to the hypervisor and to the OpenStack control plane itself, configure the user, create the project, create the networks, create the router, and it's even going ahead and doing some other stuff that is not obvious from here, but it's also going to import an image for me, and it will create some flavors, so I can just go ahead and start creating VMs without having to worry about those things. So let's just wait for a second and it will finish configuring all this information in OpenStack. Okay, there's this last question about making the floating IPs accessible only from the local host. I will just go with no, because I do expect to access this from other places. And the configuration of the OpenStack installation is done. I could go ahead right now and try to access the dashboard, or even using these credentials that I just generated to start creating VMs. But before doing that, there's some more steps that I want to do. First, let's take a look at the file that was generated with those credentials. We can see here that there's a missing new line on the last line. I think this is a small bug that's still present on this version. This is potentially giving me problems later, so I will just add a new line to that file before we continue. Now you can see that the last line is correct. And there's another thing, is that this demo project is a normal project for a normal user. The user here in this project doesn't have admin rights over the complete OpenStack. It can only manage that domain and that project. So if I need to run any other task in OpenStack itself which needs admin rights, I should be using a different set of credentials for that. And there's a command in Microstack that generates the actually it's already configured. It just extracts the admin credentials for me, and I can put that in a separate file so that when I need to run admin tasks, I can use those credentials instead. And that command is Microstack OpenRC. That is going to generate admin credentials for me. It will not ask anything. It will just extract those credentials and add to the admin OpenRC file in my case. It should be really quick to do that. And once that is done, we can see that in this file I have different user and password, and that user belongs to the admin domain. And these credentials here, as I said, would allow me to do some more stuff and administer the whole OpenStack, which is something that this guy here cannot do. Okay, so we're basically done with the configuration and credentials, and we are ready to move to the next step. Now, remember that I said that you need some manual configuration to the OVS switch so this machine can use external communications? Yeah, I said that I added a second, well, there are so many network interfaces now. Let's find the one that I added at the beginning. So this was the interface that I had by default when I created the VM. In this second interface, I added exclusively to be used by OVN, and they both are plugged externally to this VM on the same bridge. Okay, so if I go back here, I can see that this interface is down right now. This is important because if I don't enable this interface, no traffic will flow through it. So it doesn't matter if I add it to the OVN or not, it will just not receive any traffic. So because of that, I'm going to set it up. This is important. And I want to show you that the current configuration for OVS is this. You can see there's no way out to the external world here. It's just using internal interfaces for everything. Now I will add that interface to OVS. And if I go back and show the configuration again, apart from the patches and the internal interfaces, I now have this guy here, which will allow everything that is plugged to this bridge in OVS to reach the outside world through this interface. So this is the manual step that I was talking about at the beginning that needs to be done. This is probably going to be incorporated in the tool in the future, but the current beta version as it is needs this manual intervention for this to work. Okay, so now we already have everything configured. Even OVN can talk to the external world. So now we can actually start accessing the dashboard and then using or alternatively using the command line Openstack clients to talk to Openstack and start creating stuff. Let's do that. Okay, so let's start by accessing the dashboard. You can get the address for accessing the dashboard in the Juju Horizon component status message. If you do a Juju status on the OpenStack model for the Horizon component, you see here a message which tells you what is the address and the URL that you can use to access that. Let's open that into a browser. So if you go here to the browser and type that address, it will open the dashboard for us. Keep in mind that this browser here is running on my local laptop outside of that VM, and that's why it's important to use a network that is accessible from both sides. So I could just go ahead here, use one of those credentials or admin or the demo credentials, log in and use the web interface for doing tests. You are welcome to do that, but I'll be using the command line for all my other tests, so I'll just switch back to the command line. Okay, so now that we have an OpenStack installed, we have credentials to accessing that OpenStack. It's already configured. The network should be working, and the only thing that is left is we can go ahead and start using it, creating VMs and other stuff. Before I do that, I want to show you what is created and what is happening at the moment. I will import the admin credentials for that, but you really don't need to do that. You can go straight to importing the demo credentials and start creating VMs, but I want to go through some of the informations that you might find interesting to know before you do that. And for running those commands, I will be needing admin credentials. So right now I will import the admin credentials, and then I can show you that you already have some flavors created for you. You also already have one image created for you. Also, We can take a look at the hypervisor list just to make sure everything seems okay. Yep, we have one hypervisor up. It is our own VM, which is acting as a bare metal right now. It's a hypervisor. We can also take a look at the networks. I expect two networks to already exist. Yep. We have an external network and a demo network. Let's take a look at the subnets to understand what those networks are. We can see that the external network is using the network that I have on my VM. Therefore, this is a provider network for me. And I also have a virtual network that is going to be used for the VMs. It's called demo subnet, and it's using random IP address class. I can also take a look at the routers. We'll see that the configuration process already created a router for us. It's active and up. And we can even take a look at the configurations of this router. So here we can see that this router has two interfaces. One of them is internal. It has the IP.1 on that internal IP addresses that are going to begin for two VMs. The external interface for this router is using one IP of that FIP range that I allocated to Openstack. And I should be able to go ahead and ping that IP. And yeah, it is working. Right now, this traffic is going out through my first interface, which has the IP in this VM, and then going out to the bridge on my laptop and going back to the OpenStack SDN through that second interface that I have, and reaching the virtual router inside the SDN. And then I'm being able to ping it. So far, so good. Let's take a look at our key pairs. I don't have any. Yeah, but now I actually should go back to using the credentials for the demo project, because that's what I'm actually going to use to creating the VMs. So let's take a look again at the key pairs. So I want to make sure I have no key pairs yet here on this project. Yes, I don't. So I will be adding that key that I created at the very beginning of the demo to OpenStack under the name MyKey. This will be important for me to creating a VM later and being able to SSH into that VM. I need at least one key for that. Okay, so now we have all the components that we need to at least start creating a VM. And I will just go ahead and do that. Just reviewing the command here, I'm doing a server create. I will be using this Ubuntu Jammy image, which is actually the only one we have, as we saw before. I could be adding more images if I wanted, no problem. It's just that I will be using the one that we already have. This is the smallest flavor that we have on that list, the key that I just added. And I want this VM to be plugged to that internal network. We will add external IPs to this VM later. For now, I just want to plug it into an internal network. And the wait flag here is just for this command to block and return only when the server is already created. Otherwise, it will just kill the creation and I would need to query the status later. So it's a little more complicated. I prefer to do it this way. So now we wait a little bit and this VM will be created for us. Okay, so the server is created. It's running, active, everything seems okay. It got this IP here, ending 94. Using the correct flavor, using the key I asked, and okay, everything seems fine. You can also make sure it is still running at any later moment doing just a server list. Here you can also check the networks it has again and if it's active or not. And if you still want to see this information again, you can do a show in that server and you can see this again. Okay, so now for us to be able to enter this machine, we need to make it accessible from the external world. Because right now, the only way to reach this machine is being on that internal virtual network. And I only have that machine there, so I don't have any other way to get there. So I will create a floating IP on the external network. And once this floating IP is created on the external network, I will add that IP to the VM. That will be sitting on the virtual router as a NAT to the inside. And therefore, I will be able to use that external IP to enter that VM. So I have the IP created. I'll be adding that IP to the VM now. Okay, and if I check the server list again, we can see that there is one extra IP there, not this one anymore, but also this one. And this one is the IP that I will use to access this VM externally. I should be able even to ping that IP by now. Maybe not yet. Oh yeah, I already can. I was gonna say that maybe the VM is still booting and it was too early to be able to ping, but anyway, I can already ping that. So in a few seconds, I'll probably be able to enter that machine via SSH. Maybe it's too early because the boot services and the SSH service might not be up yet. If you want to see what the machine is doing while booting, you can do a console log show. It will basically show the boot log of the machine. Yep, we can see that it basically finished the boot already. It even imported my key there. So I should be able to already SSH into the machine. And yeah, that's it. I'm in. This is the test server. So I'm inside the VM, which is running in OpenStack, inside the VM of my laptop. So that's why you need nested virtualization here, because you're running a VM inside another VM. And I should from here be able to ping anything outside, not only the IP for the gateway of that network that I am in the virtual router. I am using this network here, and .1 is the IP of that virtual router. But I should also be able to ping the external IP of the router, which I don't remember the IP. Let's take a look again. Oh, sorry. Yeah, it's this one. So if I go back inside the VM, I should be able to ping that IP, which is the external interface of the router, the virtual router inside OVN. I should be able to ping my gateway on that network, which is actually my laptop. And I should even be able to ping something on the internet. Yeah, I can. So that's it. The VM is created. I could just go on using that. I could create more VMs. Just make sure that you have enough resources on the host to create, or on the VM that you are using for the test, to create extra VMs. And that's it. You should be able to use anything else that you would on a normal OpenStack. Just consider that this OpenStack installation is not complete right now. It's kind of a minimal installation. It only has the core components of OpenStack. So some of the components like Otavia, Heat, or some other components that are not really necessary for the very minimal installations are left outside for now, but they are coming in the next releases. That's why this is a beta version. It's just to test the installation tool itself, but I'm looking forward for the next versions of this tool, because I think this is going to be very, very interesting for the future. That's it. Thank you for watching, and I hope to see you in my next video. Bye.